Hi, I'm Karen Chan, SWE Global Ambassador in Canada, and it's an honor to be here with Priti Wanjara, the 2025 recipient of the Society of Women Engineers Achievement Award. This is one of SWE's Apex Awards, the highest level of awards that SWE offers, which honors individuals with 20 plus years of professional experience. My first experience with SWE was as a delegate with GM Canada back in 2004. It was my first time at a conference with more than 10,000 women engineers, and it was incredible. About 10 years ago, I was asked to be a panel speaker at a joint event between SWE and the Ontario Society of Professional Engineers, and that rekindled my interest in the organization. I became a global ambassador, I founded a professional affiliate, and I'm currently a lifetime member. Priti is the Principal Research Officer at the Aerospace Manufacturing Technology Centre at the National Research Council of Canada, which is the Government of Canada's premier research and technology organization. She received the SWE Achievement Award for landmark achievements in materials manufacturing and sustainability, for promoting and setting new standards for research excellence, and for transformational global collaborations with academia and industry. Priti, congratulations on this well-deserved achievement award, and I'm looking forward to learning more about you today.
Thank you very much, Karen, for the introduction. I'm thrilled to be here. And I want to thank you and SWE for this wonderful opportunity.
Okay, let's get into it. What excites you most about the work that you're doing now in your current role as Principal Research Officer for the Aerospace Manufacturing Technology Centre at the National Research Council of Canada?
As a Principal Research Officer at the Aerospace Manufacturing Technology Center, my role at the Council is multifaceted. So every day is different, every hour can be different. So I'm involved in developing research strategies that support the priorities of the Council and the Government of Canada. As well, I'm involved in building research collaborations, with different industry partners and academia and research organizations. I also lead and manage complex multi-year projects that involved going across different functional teams. And these teams can consist of about 15 to 25 researchers, technologists, and students who work together to try to create innovative solutions to some of the challenges that we face in manufacturing. So with these teams, my role is as a research lead in metal additive manufacturing and as well as welding technologies, and we'll talk about that later on. So I provide expert advice, guidance on the experimental methodology, on looking at, different solutions, like materials and process solutions. I conduct in-depth analysis of the results that we obtained from a microstructure, from properties. And all of this is, again, to try to find these solutions to manufacturability. I also play a supervisory role in terms of all of these projects that I'm leading. So I supervise students, visiting scientists that come from different universities, as well as, technical staff and research scientists that may be coming from other research organizations and industries. So that part of the work involves guiding people, motivating, supporting, developing a culture within the project team where people can share and collaborate, without feeling any biases. Another important part is communicating the results and reporting our findings. So usually, this is in the form of publications, so high impact journal publications, conferences, and even proprietary reports. So a lot of the work that we do often tends to be with industry. And so those reports usually are given to the client. So amongst all of this that I do, I would say what excites me most is discovery. So it's the research part of it. So from an early age, I had, I would say, a natural curiosity about everything around me. And in secondary school, I had already decided that I wanted to be an engineer. And in university, my summer internships were all in different research labs. And I think this was purposely designed or aligned by our department advisor. He recognized, I think, my research talents and passion maybe even before I did. So during my four internships, my research supervisors, were encouraging me. They supported my learning and development, and they were hinting that I should do a PhD. And this was a little, maybe, not in my plan. I didn't think that I wanted to do a PhD, but all of these positive experiences and their mentorship, it led me to continue my studies and pursue the PhD that I never thought I could really do. Anyway, on completion of my PhD, I worked for industry for a few years, so applying the research in that kind of environment. And though I had some very excellent experiences, I would say in industry, very hands-on, the dynamic research environment at the National Research Council really deepened my relationship with materials engineering. And it has allowed me to explore, I would say, my passions more thoroughly. And I think another part is the impact of my work. So the positive impact of my work on Canadian industry as well as the scientific community. These continue to drive and motivate me every day, and even after 25 years at the council.
That's amazing. Right. So you lead two one-of-a-kind facilities here in Canada, the only linear friction welding research facility and the only electron beam welding research facility. What makes them different from each other? And like, what does that work entail?
Okay, so we'll start slow. I know it's a little technical. So both electron beam welding and linear friction welding, these are advanced automated methods to join metals or like alloy parts together. And they are very crucial for manufacturing of different aerospace parts, such as gas turbine engines in the aerospace industry. So first, what is electron beam welding? So for most people, maybe relating this to a torch, that is used to melt something. So if you think about when you've gone to a restaurant and you've seen a chef, for instance, use a torch to melt or caramelize sugar, on your creme brulee, right? So that's a torch. So the electron beam welding method is a very focused, high energy beam or torch that heats and it melts the metal. So it can go high enough in temperature to melt all metals that we have. Okay. Um, by contrast, linear friction welding doesn't melt anything. It's a solid state welding process. And so the way that technology works is when you have two surfaces together, and it's like if you do this with your hands. The friction between the two surfaces that are, in contact with each other, when you're rubbing them, it causes heating. And that heating causes the surface to become softened, so like
Mhm.
deforming plastically. So what is that plastic deformation? Plastic deformation can be compared to like Play-Doh or plasticine. So, you can everybody's played with Play-Doh and you shape, you mold, you shape into something, right? So that's exactly what we do in linear friction welding. We rub things together, we heat the surface, and then we apply a pressure at the end, which causes the two metal parts to come together and solidify and bond carefully together. And that bonding is actually very strong because it's done in the solid state. So in the liquid state, often there's a little bit more damage that happens from the welding process. So when I started my research with these two methods in 2002, there was very little information in literature on these technologies, especially for what I would call difficult to join metals. So in the aerospace industry, typically instead of welding, they relied on machining to a final shape. Okay,
Mhm.
so like they take something big, come off and machine it to the final part shape. But continuously, in aerospace, we want to be able to have very high fuel efficiency. So you want to be able to go further with less fuel so you can be very light. So what they had to do over the years is to evolve light weighting of the whole aircraft. And you see that even in the automotive industry, we're trying to have lighter cars, right? And the other thing is that they try to increase the engine temperature. And if you increase the temperature of the gas turbine engine, this makes you more fuel efficient.
Mhm.
So both of these processes, or both of these approaches, I should say, led to requiring the design of very advanced materials. And those materials are very costly. So if you're making them and then machining them, that hurts.
Mhm.
And so joining then became very important and proprietary for the industry. And so that kind of explains why there's very little published on them. Um, and initially, some of the joints were mechanical. Mechanical joints can be thought about like you use a nail or a screw and you put one part into another. But when you use some sort of mechanical fastener, that nail or screw adds weight. So that doesn't help in the lightweighting. So welding something together with the electron beam or with the linear friction machine, then these type of technologies allowed you to join without that nail or screw added. And these are advanced technologies that gave good performance. So in aerospace, performance is important, but reliability is even more important. So, in other words, you can take a debit on your properties, but it should be consistent. If today you get very high performance and then the next day you get low performance, then there's no
Mhm.
reliability. And that's a concern for safety. At the council with the electron beam welding technology, I started first by looking at titanium and nickel-based superalloys, and that's where I would say the aerospace industry was at the time. There was some publications on that, but in terms of linear friction welding, there was um, a handful, I would say, that only I would say more like two or three publications on a single titanium alloy. So in the last 20 years, I've looked at increasing our general knowledge about the applicability of these two technologies because I've been very privileged to have such unique facilities. And I've tried to advance their understanding for a range of different alloys like aluminum, magnesium, titanium, copper, steels, nickel-based superalloys. And what that body of knowledge has been able to do is really help all the different industries look at these technologies for their applications. So the research is not just that aimed at finding some properties, but actually linking, their digital technology so you can really control the process. So trying to link that process, the variables in the process, and controlling those variables and what you get in terms of the microstructure and the properties, especially like fatigue resistance, which is very important in many industries.
Mhm.
And that linkage, has been an important driver for that sustainability and that confidence in that material's performance. And so then it could be used in engineering for different sectors, not only transportation, but power generation, clean energy, and so on and so forth.
As you were talking, I was thinking through all about my own experiences with welding and primarily through the automotive plant
Yes,
and the sheet metal, right? And I
right.
will say, I'm a mechanical engineer. My favorite robot has always been the welding robot, and watching that go and weld a
Yes.
million things in like the span of a minute, it's always really cool. Okay, we're going to switch tracks a little bit. So you established a mentorship program, a STEM mentorship program at the National Research Council. For those who are looking to establish their own mentorship programs, what's some advice that you can give? What are three things you wish you'd known when you were starting out?
Okay, so first, I want to say that I had some amazing mentors in that program. So we had a lot of success because of, I think, because of their involvement in it. So a lot of people know that the NRC established a mentorship program for all employees in 2021. But what many people don't know is that to establish that program, there was a team of women, including myself, that led a focused STEM mentorship pilot project.
Okay.
And this was done about 1 year before, during COVID, actually, in
Mm,
2020. I highly recommend a pilot such as that. So the launching of the pilot had many benefits for us. And the key one was being able to test the mentor-mentee matching platform
Mm,
or the app. Having a good app that actually addresses what you want out of your mentorship program is key. So we recognized through our pilot study that the platform we selected was not a good fit for our organization. So basically, the platform we were using, it was not providing streamlined administration.
mm,
It didn't give us an adequate level of communication and accessibility. NRC is large. It's across Canada, so we needed that flexibility.
mm,
It also was having, we couldn't get some data analysis from it, so driving, data-driven insights or anything like that, we couldn't really drive that. And so we felt that these were very crucial for us at NRC to have a successful program, but also to give good satisfaction to the participants. Because if your experience on the platform is not satisfactory, you won't go back to it, and you might abandon doing different mentorship relationships, right? So this was, I would say this is number one.
mhm,
Number two, I would say another important learning was we focused on a very small group of STEM participants. So I mentioned that NRC is large. The council actually has 4,000 employees,
wow.
and we're in 12 different research centers, and we have 24 locations across Canada. So, our focus pilot was really aiming to work with a team of employees and their experiences. And we focused our pilot program on about 160 STEM participants, so still a fair number of participants. Their experiences were very useful in designing a very robust mentorship program at NRC for all the employees.
Mhm,
But without that input, I think, the first experiences may not have been where they landed, in 2021. So, yeah, kudos to the whole team. The third thing is to gain leadership support. I would say that's very important. And so as I said, we were very lucky from the onset. We had support from our leadership to even run the STEM mentorship pilot. So I attribute its success and our program success to our management. That really encouraged us and was involved in us. So even before we launched our study, our pilot was championed by two vice presidents at NRC,
mhm,
Dr. Genevieve Tanguay, who was at the time in our Emerging Technologies division, and Emily Harrison from our Human Resources division. They provided support to us in the form of resources, but also visibility, at the top level and endorsing it to everyone. And this reinforced the importance of our pilot. And
mhm,
also, I would say it developed a more inclusive and diverse work culture at the NRC.
mhm,
So I would say these are the three main things. Of course, every organization is different. As I
mhm,
said, we're challenged by being a very large organization, but I think there are more and more of these very large
mhm.
organizations. NRC is not the only one. There are industries having tens of thousands of people and not even in one country, right? So, as your organization is bigger, then these pilot type of studies, I think, are the most important to make sure the full experience is launched carefully.
So the three things are to have a pilot,
Yep,
to design the pilot well for your
yep,
needs, and to
yep.
have leadership support. So
Yes.
I love the first two are very engineering, right? Like test
Yes,
and learn in a controlled environment. To close out our conversation, we're going to do a fun lightning round of questions. Are you ready?
I'm ready.
Okay. What's your favorite thing to do on weekends?
Okay, so I really value my family a lot. And so my favorite thing to do on the weekend is catching up with my families. I'm a busy person, I work many hours. And so I call a lot of people on the weekends, but I also love catching up with my neighbors and my friends, so that's my favorite thing to do on the weekend. If I don't get to do that, I'm very sad.
How about reading? What are you reading right now?
I'm reading All the Light We Cannot See by Anthony Doerr. So I like a lot of different types of books. And this book is very interesting to me because it offers a combination of mystery,
Mhm.
science, and history. So I like each of those, but blended together, it's such a unique combination. Honestly, I'm really enjoying it. Sometimes, I have to turn myself away from it because I have work to do.
What's your favorite thing to do with people who are visiting you?
Okay, so in general, I like people to learn about the Quebec culture, and
Mhm.
I like them to experience it through food. So that's the first thing. And if people get interested to that, then maybe they'll want to learn more about other things. So I like to bring them to. So even people who come, like visiting scientists that come, or people just come for a day or two, I'll make sure we go to a restaurant where they could try like our smoked meat.
Mhm.
And poutine that should be tried at least once.
Yeah.
And maple syrup is always very nice. So for dessert, maple syrup with crepes and the artisan cheeses. So Quebec is really known for a lot of great cheeses. So things like this. And of course, with our family and friends, we're always looking at going to different restaurants and trying new things. So yeah, that's what I like to do.
I will say my childhood favorite was Saint Hubert. And so every time we go to Quebec, first place we go. So, because you can't get
Yes,
that in Ontario. Okay,
yes.
what's the last place you traveled to?
Okay, so this summer, my husband and I vacationed for about 3 weeks, and we visited Ireland, Scotland, Bath, and Stonehenge in England. And those were all on my bucket list. And in the future, I hope to visit. So I have a lot on my bucket list, but in the future, Iceland is on my bucket list that I want to be able to do one day.
Amazing. You love gardening. So what's one green thumb moment that you're the most proud of?
So I can't say it's one moment, but I would say what is a proud green thumb moment for me is always my flowering blooms. So my spring starts with the blooming of large pink flowers on my magnolia tree. And just when those petals are starting to fall, my flowering almond tree goes into full bloom alongside my dwarf lilac, which is very fragrant. And then I have some peonies that bloom next, and this is the beginning of summer. And so when summer comes around, my clematis go in bloom, then the roses bloom all summer. And as fall comes in, the roses are still there miraculously, and so are the hydrangeas. And all of these bring a lot of color to my garden, different fragrances to my garden, and that really is my green thumb moment.
That sounds amazing. It's more than a moment. That's like a huge accomplishment.
Yeah, I guess winter is a little different, but I was trying to find something that would survive and give me something in the winter, but it's kind of tough here.
It's tough in this region for sure.
Yes.
Okay, congratulations again, Priti, on receiving the prestigious 2025 SWE Achievement Award. And thank you for sharing your expertise with the women and allies in our community.
Thank you, Karen, for having me. It has been a real pleasure to meet with you today and share my experiences. I hope that these are aspiring to the listeners and future engineers. I also want to thank the Society of Women Engineers for this award. Truly, it's been such an amazing experience and such an honor to be this year's recipient. Thank you very much.
For anyone who wants to learn more about Preeti or other incredible Sweet Apex Award recipients this year, you can read their profiles in the 2025 conference issue of SWE magazine, which is available online at swe.org/SWE-magazine. We also encourage you to visit the We25 Awards Hall at we25awards.swe.org, where you can view the complete list of this year's SWE Awards recipients and leave them a note of congratulations. I'm Karen Chan, and thank you for joining us today.